in the lesson you missed, we covered interest-only loans. And on face value, interest-only loans seem a little bit crazy. Like, you really do want to reduce the principal, so why wouldn't you pay more than just the interest? But there's a legit reason why, and we can see it in the example. So just say, for argument's sake, Jane wants to buy some shares, but she doesn't have any money to buy these shares. She's got this, shall we say, hot tip about these shares, right? So she is pretty sure she's got, if she invests in these shares, she's going to make some money. So what she does, she goes to the bank and says, all right, can I borrow $50,000? What she's going to do is just pay interest only on it, 9% per annum, compounding monthly. And what she's banking on is that the fact that the interest charged to the $50,000 will be less than what she actually will make on the shares. So just say in 12 months the shares are worth $65,000, the compounds will only be worth $55,000. She's just made 10 grand just like that. Sounds great, doesn't it? And so why doesn't everyone do it? Because we don't get hot tips. They don't exist. It's a gamble. And so an interest-only loan is a little bit of a gamble, one that I certainly wouldn't make. Let's work out our interest using this formula here first of all, and then we'll use Financial Solver. So we've got 9% per annum compounding monthly times the 50 grand that she borrows. Let's go over to the calc and see what it is. 9 over 12 over 100 times $50,000. Calc's proposing it's $375 a month. Let's see if that's right. 9 on 12 on 100, add 1, and we'll put it into some recursion and see whether it does indeed stay at $50,000. So we're going to multiply that by 1.0075 and remove the proposed monthly repayment to keep the principal at $50,000. So if I hit enter now, what should happen is that 50,000 comes up, and it does. So she's basically paying off the interest every month. We can do this with Financial Solver as well. It's my preferred method. The more you can use Financial Solver, the more you'll understand how it works. Let's go compound interest. And what we'll do is we'll do this after one compounding period. That's all we want to know is what's the interest on one compounding period, because it'll be the same every time it happens. It's 9%. The present value of the loan, the bank gives us $50,000 to invest. We don't know the payments. We do know the future value will be the $50,000 I pay back. It's 12 payments a year, 12 compounds a year. Payments are $375 going from me to the bank. Alright, so in your notes, make sure you just fill in all of those values there, N, I%, blah, 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 and 375. Okay, in this example here, $180,000 to buy a house on an interest-only loan, compounding fortnightly, and we want to examine what the fortnightly payments actually are. Alright, so let's do it using the formula first. We'll go D equals 7.6 compounding fortnightly times 180,000. So that's 7.6 over 26 over 100 multiplied by 180, 3 zeros. To the nearest cent means they want us to round it to 2 decimal places. So it's $526.15. Again, let's pop that into Financial Solver. I reckon that's a neater way of doing it. Again, we just are interested after one compounding period, the amount of interest charged. 7.6 on $180,000. We want to return the $180,000 in time. What happened? You've got to be a little bit careful here, so I've just jumped straight into it and saying the payments are 1,140. And if I didn't do it like this, I probably would have written that down. I've got to make sure I adjust the payments a year and compounds per year. 526.15. If you ever want to check your answer, pop it into a recurrence relation, and it should keep the balance of the loan, or the amount owing on the loan, at $180,000 roughly. That won't exactly, because we'd have to round it, but it'll work. Right, so again in your notes, make sure you pop down I%, PV, all of that sort of stuff, and the fact that they owe $526.15 a fortnight to keep the loan at $180,000. All right, on to annuities. Again, it's just another application of where you can use in Financial Solver. You can do a little bit on recurrence relations here. It's identical to a reducing balance loan. The only difference is the value of the loan represents how much is owed at any time, whereas the value of the annuity represents how much money is left in the investment. So let's see this again in an example of why you'd actually do it. So Reza plans to travel overseas for 6 months, invest $12,000 in an annuity that earns interest at the rate of 6% per annum, and providing him with a monthly income of $2,035 per month for 6 months. Right, so again, why is he doing this? Well, he could travel overseas and keep the $12,000 in his suitcase, in a sock, hidden in his shoe, in his wallet, but really there's going to be no action on that amount. It's going to be $12,000 at the end of 6 months. So why doesn't he stick it in the bank, where at least it's going to compound at whatever interest rate they're going to give him? And it will kind of give him, if you want to sort of say it, more bang for buck. Okay, so maybe that $12,000 becomes, I don't know, $12,500. You can't argue with $500 free dollars. So that's why he'd be doing this. Okay, it's just to get some action on that money rather than it just sort of sitting around. I mean, for one thing, if he's traveling overseas, and imagine Reza is 21 years old, he's probably staying in youth hostels, the money's going to get stolen, blah, blah, blah. So stick it in the bank, compounds, and it's safe that way. All right, so they want us first of all to model the annuity using a recurrence relation. B0 is how much he invested, so that is the $12,000. Vn plus 1 is the rate. All right, so we've got 6% per annum. The rate is 6% per annum. So and we want to split that monthly. So we can write that as a decimal or a fraction. Oh, let's just go with a fraction. That's 6 over 12 over 100 plus 1 times Vn, the previous term, subtract the fortnightly or the monthly income he's taking out, $235. Okay, so that's the recurrence relation. Okay, so there you go. That is the recurrence relation there. And why have they got that and I've got that? Ooh, is it wrong? No, it's not. Just convert that to a decimal and that's what it is. But as the decimals get bigger and bigger and bigger, it might be easier and safer just to use the exact value rather than the decimal. Alright, so use your calculator to determine recursively the value of the annuity after Reza has received 3 payments. Alright, so let's go into main, chuck in the amount that Reza has brought to the table for his holiday. That's 12 grand. We're going to multiply that by 1.005 and subtract 2035. So that's after he has received the first, second, and third. Okay, so the value of the annuity after he's received 3 payments is $5,909.96. That's basically what he's got left of his kind of travel money, I suppose. Is the annuity fully paid out after 6 monthly payments? If not, how much will the last payment have to be? Alright, so we've done 3 payments there. Let's do 4th, 5th, 6th. Okay, there's something that's gone wrong here. Okay, now why do I know something's gone wrong? I know something's gone wrong because have a look at that amount there. Never going to be out by that much. And because that implies that on the last payment, he has overdrawn the account by $189. Yeah, so look, what we're going to do is just go back and check out something. And I've done the classic, put 3 decimal places instead of 2. So this amount will be wrong as well. Sorry. Let's go around one more time. Invest $12,000, multiply by 1.005, subtract 2035. Well, first payment, second payment, third payment. Alright, so there it is, and 6045.33. So that's what he should have, and I'll quickly check my answers, and that's what I got when I did it in class. So that's good. Now at this point here, I also actually showed the class how to do this with sequence generator as well. So I'll show you how to do that one. So we now went into menu and used sequence to do this. You might have remembered doing this earlier in the start of the year. So what we can do here is put our recurrence relation in. They use Vn plus 1. These guys are using An plus 1. So that's 1.005 multiplied by, now where do I get Vn, or in this case An? Go up the top here, click it, take away 2035. Got to make sure I replace this with my initial value, check it, and run the sequence. There's 5 iterations of the sequence. Let's keep it going to 15 and see what happens. And you can see here that the annuity will basically run out. So it says here, is the annuity fully paid out after 6 monthly payments have been made? If not, how much will the last payment have to be to ensure the annuity terminates after 6 months? So this is after the 1st, 2nd, 3rd, 4th, 5th, 6th. So basically he's got 88 cents left in the annuity after he's taken out the $235 from the account. So he's not going to then go, all right, I've got enough, or I'm going to go on holidays, stay on holidays for a 7th month. He's basically going to terminate the annuity, and what he'll do is take out the $235 plus the remaining 88 cents in the account to be a total of that'll be his last payment. The amortization tables, again, the examiners went through this and said they're really important to understand. And you can see there the last payment received is not the same as the rest of them, because they're not going to leave 88 cents there. He'll take that 88 cents out as well. Alright, let's go to Financial Solver and do this example here. It's a tough one, but let's get through it. Got $200,000 in an annuity paying 5% compound interest per annum, compounding monthly. If he wishes to be paid monthly payments for 10 years, how much will he receive each month? Alright, so let's run it. Okay, so if he wishes to pay monthly payments for 10 years, so that's N, 10 times 12, 10 years of 12 months. Interest is 5%. The investment is $200,000. Okay, and this is an investment. So, in a way, you think about it like I'm giving the bank $200,000. So the sign convention is to use negative. Don't know what the payments are, but I know that the implication with annuity is that the future value is going to be nothing. I'm going to terminate the annuity. Payments per year and compounds a year go back to 12 because this is a compounding monthly question. And the payments in this case will be $2,121.31. Okay, so that's essentially what the bank will then give him each month as a payment, I suppose. All right, so really important again on the sign convention for that one. Now, don't forget with this example, girls, to write out your N, I%, PV, all of those things, so you can see what you did. If he receives a regular monthly payment of $3,000, how long will the annuity last? Give your answer to the correct to the nearest month. All right, so it's the same deal here, except this time what they are doing is they're not telling us the number of payments, but they are telling us that he wants $3,000 a month. So we change that. All of these conditions are the same, except the number of months. And it's basically saying on the $200,000 investment, he'll be able to live at $3,000 a month for 78.2 months. Nearest month, though, means we don't round that to 79. We actually say that that is 78 months. Because that 0.2 of a month is 0.2 of $3,000, and you can't live for that month. So basically it's 78 months. So we round down in this case, as opposed to investments, which often will round up to the 79. Okay, now just say for argument's sake he knows that he needs $2,500 for living expenses each month, and he's got this $200. He wants to live for 10 years. That's what he's banking on with his $200,000. This is a typical like superannuation question hidden in this. So he knows that the number of periods goes back to 10 by 12. Interest is still the same. This time though, he knows the payments will be $2,500. Interest is not the same, my bad. It's again unknown because they're saying what will be the interest rate to produce this deal. That is over 120 compounds. You invest 200, taking out 2,500. Let's check it out. He's basically after an interest rate of that to one decimal place. 8.7% is what he is looking for. I've lost my pen. Where is it? So 8.7%. Okay. So girls, make sure also again you fill in all of those things in I%, blah blah blah. You'll have to do that in the assessment task as well. So well worth getting in the habit of doing it. Plus, again, if you're going through this example at a later time, you'll be able to see, oh yeah, that's what I filled in, or that's why I did that. Okay, so there's annuities and interest-only loans. Next up, we've got perpetuities and compound interest investments with regular additions. Girls, they're exactly the same as what we've just done, just different parameters in Financial Solver. So you'll see that once you get this stuff down pat, you'll be able to do any problem.